Our first question for horizontal asymptotes is f of x equals 2x to the third plus 2 over x squared plus 4x. Again, for horizontal asymptotes, you compare the degree or the highest exponent of the numerator and denominator. In this case, the numerator has a higher degree than the denominator. So looking at the definitions of horizontal, a higher degree in the numerator means there is no horizontal. Second question, g of x equals x to the third minus 2 over x to the fifth. And again, you look at the degree or highest exponent. In this case, the numerator has a lower degree than the denominator. And looking at the definition, a lower degree in the denominator means the horizontal is y equals 0. Again, when we graph, the asymptote is a line that does not cross the graph, so we have a line at y equals 0 that the graph does not cross. And the last question for horizontal asymptotes is h of x equals 2x squared plus 6x minus 5 over 3x squared minus 4x plus 2. And again, for horizontal asymptotes, you look at the highest exponent or degree. In this case, they're both the same. The definition is a fraction for the leading coefficients. The leading coefficients are the number in front of the highest exponent. In this case, it's 2 over 3. So our horizontal would be y equals 2 over 3, or 2/3. The last section of notes today is titled Graphing. Rational functions. To graph rational functions, we'll use vertical asymptotes, holes, and horizontal asymptotes. The first question is f of x equals 2x over x plus 1. First thing we'll do on this is find the vertical asymptotes, the holes, and also horizontal asymptotes. Once we find those three, then we can graph the function. Vertical asymptotes, again, you set the denominator equal to 0. X plus 1 equals 0. In this case, x would equal -1. The holes on the graph, again, if a factor cancels out, we have x plus 1, but there's no x plus 1, so there is no holes. The horizontal asymptotes, you look at the degree of the numerator and denominator. Both have the same degree or same exponent, which means you'll make a fraction from the coefficients 2 over 1 or just 2. And the horizontal is y equals 2. Using these, we can start to graph. Draw a xy axis. A vertical asymptote at x equals -1. A vertical asymptote will be a straight dashed line that goes through x equals -1. And when we graph, the line of the graph cannot go through the vertical asymptote. There are no holes, so we don't have to worry about the holes. Horizontal, the same thing as the vertical, except it's horizontal at y equals 2. And you have a dashed line going across, crossing at y equals 2. Again, the graph cannot cross the horizontal asymptote. With the vertical and horizontal asymptotes, we have 4 sections of the graph. Rational functions on the left side of the graph will either use the top or bottom section. Basically, you'll have a curve either on top of the graph or you'll have a curve on the bottom of the graph. The same thing for the right section, because it cannot cross the vertical asymptote. You'll either have a curve on top of the graph or a curve on bottom of the graph. To decide whether it's top or bottom, you can use a t-table. And on the to decide which points to use in the t-table, we want to pick one point to the left of the vertical asymptote and one point to the right. This vertical asymptote is at x equals -1, so the next point over would be -2. -2 we can plug back into our original equation. -2 times 2 would be -4, and -2 plus 1 would be -1. -4 over -1, the y value would be +4. So if we graph this point, -2, +4, this point tells us the graph is on top of the horizontal asymptote and not on the bottom. Once you know it's on top, you'll basically curve the graph. It goes parallel to the vertical asymptote. It cannot cross the vertical asymptote. Same thing when it gets towards the horizontal asymptote. It has to curve and go parallel to the horizontal asymptote. That's the left side of the graph. And then we'll have the same thing on the right side of the graph. The curve will either be on top or it will be on the bottom, and you have to pick another point for the t-table. X equals -1. We can pick a point to the right, which would be 0. Plug 0 into the original equation. 2 times 0 would be 0. 0 plus 1 would be 1. 0 over 1 would be 0. So our point is 0, 0. And again, the graph is either on top or bottom of the horizontal asymptote. This point tells us it's on bottom. If you draw a curve that goes parallel to the vertical asymptote, continues through the point, and again goes parallel to the horizontal asymptotes, the graph can never cross a asymptote. Next question that we'll do for graphing rational expressions is g of x equals 6 over x squared plus x minus 6. And again, the first step when you graph a rational expression is you want to find the vertical asymptotes, the holes, and horizontal asymptotes. First step again, the denominator you set equal to 0. This one we can factor. This question factors to x plus 3 and x minus 2. If you set that equal to 0, you'll have x equals -3 and x equals +2. These will both be our vertical asymptotes. X equals -3 and x equals 2. The holes again, the factors, you have to have the same factor in the numerator and denominator, which we don't, so there are no holes. Horizontal asymptotes, you look at the degree or highest exponent. The numerator does not have an exponent, but it's kind of like x to the 0 power, so the numerator has a less degree. A lower degree means y is equal to 0. Once you have your asymptotes, you can draw the xy axis. Vertical, x equals -3. Again, would be a dashed line at x equals -3 that the graph cannot cross. Also, x equals 2 will be another vertical line that the graph cannot cross. There are no holes, and the horizontal asymptote is at y equals 0, which is the x-axis. So we'll have a dashed line going across the x-axis that the graph cannot cross. On this one, we have 6 sections. We have 2 sections on the left, 2 sections in the middle, and 2 sections on the right. Same idea as the last problem. The graph can either be on top or bottom of each section. You'll either have a curve on top or a curve on bottom. The middle sections will be like parabolas. You'll either have a parabola on top or a parabola on the bottom, and the right side will be either curve on top or curve on bottom. To decide top or bottom, again, you can do a t-table. We'll pick one point to the left of the asymptotes, one point that's in the middle, and one point that's on the right. This is at -3, so we can pick the next point over, which is -4. Going back to the original question, you have 6 on top. If you plug a -4 in, -4 squared would be 16, plus x, which would be -4, and -6. 16 minus 4 would be 12, 12 minus 6 would be 6, and 6 over 6 would be 1. Graphing that point, -4, +1, tells you again the graph is on top of this first section. Curve the graph by the asymptotes, and it goes parallel by the horizontal and vertical asymptotes. Next point we'll pick is in the middle of the graph. Anything between -3 and +2, nice easy point would be 0. We'll still have 6 on top of the fraction. 0 squared would be 0, plus 0 is 0, and -6. 6 divided by -6 would be -1. So the point in the middle graph is 0 and -1. Again, we have a horizontal asymptote at y equals 0, so the graph cannot cross here. We know the graph's on the bottom with our point, so you'll basically have a parabola that goes through that point and goes parallel by the vertical asymptotes and turns around before the horizontal asymptote. Last part of this question is the right side of the graph. We need to figure out if it's on top or bottom. This point's at 2, so your next point over, you can pick x equals 3. 6 again, just a number on top of the fraction. 3 squared would be 9, plus 3, and -6. 9 plus 3 is 12, minus 6 would also be 6. So 6 over 6 would be 1. So our point 3, 1 tells us the graph is on top of this section. So again, you curve the graph between the asymptotes, and you have your answer. Last problem for this section. The equation is h of x equals x squared minus 25 over x minus 5. And again, the first steps on these, you want to find the vertical asymptotes, find the holes, and find the horizontal asymptotes. Vertical, again, you set the denominator equal to 0. So x would equal 5. Holes, again, are when a factor cancels out. On the denominator, we have x minus 5. The numerator doesn't have x minus 5, but you can actually factor this. Difference of squares to x plus 5 and x minus 5. If you factor it, you'll have x minus 5 in the denominator, x minus 5 in the numerator, so these factors would cancel, setting that same factor equal to 0, and that's where a whole x equal 5. Like before, if you have the same vertical and whole, you can cross off the vertical, since you'll be graphing the same number. Since there's only one vertical and we crossed it off, there's actually no vertical asymptotes for this graph. There's a hole, and for the horizontal, you look at the degree of the original problem, x squared over x. The numerator has a higher degree, Looking back at the definition, if the numerator is higher, then there is no horizontal. So for this graph, we have no vertical, no horizontal, and we only have a hole. If you rewrite the question, h of x, the x minus 5's canceled out. All we have left is x plus 5. Graphing this one would just be a linear line, mx plus b, where n is equal to 1, b is equal to 5, and you can draw your graph from there. Keep in mind there's no vertical, no horizontal for this graph, so we don't have any dashed lines. If we start at b equals 5, or the y-intercept, b equals 5, the slope is 1, so we'll go up one spot, over one spot. The difference on this graph between a normal mx plus b linear line and this graph is there is a hole at x equals 5. What that means is we have to go over to x equals 5. If we start to draw the line, figure out where the line is going to be at x equals 5, we'll put an open spot or an open circle for a hole. The line goes to that hole, the line is going to be missing this point, and then the line will continue on like normal. And that would be the answer to the question. So our original equation, x squared minus 25 over x minus 5, is a straight line. With one exception, there's a hole at x equals 5. Title of the first section is Review, Graphing, Rational Equations. In this section, we'll review graphing rational equations, which has vertical, horizontal, asymptotes, and holes. First equation we'll graph, f of x equals x plus 2, all divided by x squared minus x minus 6. When first graphing, we want to find the vertical asymptotes, which again are where the denominator is equal to 0. So we can first factor and find the values where x is equal to 0. Factoring x squared minus x minus 6, you could factor this using the diamond method. Two numbers that multiply to get negative 6 and add to get negative 1. Those numbers would be negative 3 and positive 2. So this would factor to x minus 3 and x plus 2. Setting this equal to 0, x minus 3 equals 0, we'll have x equals 3. And x plus 2 equals 0, x would equal negative 2. So the vertical asymptotes for this graph would be x equals 3 and x equals negative 2. For the horizontal asymptotes, we can look at the degree or highest exponent in the original equation. The numerator, we have x to the first, or a degree of 1. The denominator, we have x squared, or a degree of 2. So the numerator has a lower degree than the denominator. Anytime the numerator is a lower degree, the horizontal asymptote will be y equals 0. And last part before a graph are to find the holes. Holes again are where the factor cancels. In the numerator we have a factor of x plus 2, And the denominator, we have a factor of x plus 2 also. So if we cancel these out, x plus 2 divided by x plus 2, we'd set this factor equal to 0. So our whole would be at x equals negative 2. The answer to x plus 2 equals 0. And again, when you have a whole and a vertical asymptote with the same number, we can cross off the same number for the vertical asymptote. Since we're graphing, we only have to graph one, which would be a whole at x equals negative 2. From here we can draw the graph. The vertical asymptote at x equals 3. Again, a vertical asymptote is a dashed line, in this case going straight up and down, in which the graph cannot pass or go through the vertical line. The horizontal asymptote at y equals 0. Y equals 0 is also on the x-axis. So we'll have another dashed line across the x-axis, which means again the graph cannot cross the horizontal asymptote or cross over the x-axis. After we start the graph, we'll put a whole at x equals negative 2. When we have the vertical and horizontal asymptotes, now we have 4 sections to the graph. Again, the graph is on the left side of the vertical asymptote. It will either curve on the top or curve on the bottom. And same thing on the right hand side. The graph will either curve along the top section or curve in the bottom section. To figure out if it's the top or the bottom for the graph, we do a t-table. Picking numbers, we can pick one number to the left of the vertical asymptote and one number to the right. We can pick any number to the left. For example, we could pick 2, 1, 0, or any negative numbers. Easiest number to pick would be 0, since 0 is easy to add, subtract, and multiply by. If x equals 0, plugging a 0 into our original equation. The original equation, again, at the beginning of the question, x plus 2 would be 0 plus 2, which would be 2. And the denominator, x squared minus x minus 6. All the x's would cancel or be 0, and we'll be dividing by negative 6. Reducing this, we'll have negative 1/3. Since we have a negative number, that means the y value is below the horizontal asymptote. So at 0, negative 1/3, you could graph that point. And since the point's below, that means the graph will curve going parallel or close to the horizontal asymptote, curving, and going parallel or close to the vertical asymptote also. There is a whole at x equals negative 2. So if we go over to negative 2, we can draw an open circle. This open circle represents this point as undefined. The graph skips this point, but does not include the point. For the second half of the graph on the right side, the x vertical asymptote is at x equals 3. So we want to pick a number to the right of 3. In this case, again, we could pick 4 or any number 4 or bigger. If we use 4, plugging the 4 in again to the original equation, the numerator is x plus 2 or 4 plus 2, which would be 6. And the denominator was x squared. 4 squared would be 16. Minus x would be minus 4 and minus 6. Simplifying this out, 16 minus 4 would be 12. Minus 6 would be 6. And we'll have 6 divided by 6, which would be 1. Again, y equals 1 or a positive value, which means the graph in this section is the top right corner. And again, the graph will curve next to the vertical asymptote and go next to the horizontal asymptote also. And that would be the graph for the question. Second question and last question for the section. G of x equals x squared plus 6x plus 5, all divided by x plus 1. Again, graphing this rational expression where we have variables or x's for the numerator and denominator. We can find the vertical asymptotes. Vertical again is where the denominator will be equal to 0 or undefined. X plus 1 equals 0. That means the vertical solving x plus 1 equals 0 will have x equals negative 1. For the horizontal asymptotes, Horizontal, again, look at the degree or highest exponent for numerator and denominator. This time the numerator has a higher degree or higher exponent than the denominator. Anytime the numerator is higher, horizontal will be none. So there is no horizontal asymptotes. And last part before a graph is to find the holes. Holes, again, are factors which cancel out in the numerator and denominator. The numerator we can first factor, x squared plus 6x plus 5. We can factor that to two sets of parentheses. Two numbers that multiply to be 5 and add to get 6 would be x plus 5 and x plus 1. Looking at the common factors, we have x plus 1 in the numerator and x plus 1 in the denominator. So these two factors would cancel or give us a whole. Again, setting this equal to 0, x plus 1 equals 0, the whole would be at x equals negative 1. And when you have the vertical asymptote and the whole as the same number, we can cross off or ignore the vertical asymptote, and the whole would take the place on the graph. From here we can draw the xy axis. This time there are no vertical asymptotes to graph. Anytime there's no vertical asymptotes to graph, the graph will not curve up or down in any section, but will rather be a continuous graph, except for the spot that we have a hole. And there's none horizontal asymptotes, so there'll be no curving up or down. We'll basically have a single graph with a single hole. Looking back at the equation, if we cancel out the x plus 1 for the numerator and denominator, the only factor or only question we have left is x plus 5. If we set this equal to y, the original equation will be the graph of y equals x plus 5. Only difference is we'll have a hole at x equals negative 1. Graphing this function, which is a linear function, we can graph using mx plus b, slope-intercept form. The slope m, number in front of x, would be 1, or 1 over 1, and b, the y-intercept, last number, which would be 5. So graphing, we can start at the y-intercept, which is 5. Having a slope of 1, or 1 over 1, we'll go up one spot and to the right one spot. We would connect this to make a straight line. The only difference is we have a hole at negative 1. So if we go over to negative 1 to where the graph would be, we'll have an open circle, meaning this point will not exist for the graph, but every other point along the graph will exist. So the function that we graphed is the exact same graph as x plus 5 with a hole at x equals negative 1. Title of the last section today is Graphs with more than one vertical asymptote. In this section, we'll look at a graph that has more than one vertical asymptote, which will change the number of sections that we'll graph for the equation. First equation and only equation for the section, f of x equals 3 divided by x squared plus 4x minus 5. Again, graphing rational functions where we have variables or x's in the denominator. We can first find the vertical asymptotes. Find the vertical asymptotes where the denominator is equal to 0, which in this case